Somewhere in the universe, a star is dying right now. Its core is collapsing inward, faster and faster, until gravity wins. And in the next instant, the star explodes. Not like a bomb, not like anything we know. For a brief moment, that single dying star becomes brighter than an entire galaxy. Billions of stars, outshined by one. Now imagine something else. Imagine that explosion, not millions of light years away, but near us, cosmically close. Close enough that our entire solar system is inside the blast zone. This isn't a fight, it's an extinction event. A supernova happens when a massive star reaches the end of its life. For millions of years, it burns fuel in its core. Hydrogen, then helium, then heavier and heavier elements. But eventually, the fuel runs out. And when that happens, the delicate balance holding the star together collapses. Pressure drops, gravity takes over. The core implodes. Matter crashes inward at thousands of kilometers per second. The center of the star collapses into an ultra-dense core. And then, the rebound. The outer layers of the star detonate outward in one of the most violent events in the universe, a supernova. In seconds, that star releases more energy than our sun will produce in its entire lifetime. Billions of years of solar energy released in moments. But the explosion itself is only the beginning. Because what comes next travels across space. A shockwave, expanding outward at thousands of kilometers per second. Imagine a wall of energy racing through the galaxy. Radiation arrives first. Gamma rays, X-rays, charged particles moving close to the speed of light. Space isn't truly empty. It's filled with gas, dust, and fragile planetary systems. And that wave doesn't stop for any of them. Now imagine watching this from Earth. At first, nothing seems wrong. The night sky changes. A new star appears. Except it isn't a star. It's a supernova hundreds of light years away, brighter than Venus, brighter than the moon, visible even during the day, beautiful, silent. But the danger is already on its way, because radiation travels fast, and space offers no shield. If a supernova exploded within about 30 light years of Earth, the ozone layer would collapse. Without that shield, ultraviolet radiation from our own sun would flood the planet. The surface would burn. Food chains would collapse. Plants would struggle to survive. Oceans would begin to destabilize. Life on Earth would face one of the worst extinction events in its history. And that's only the radiation. If the explosion were closer, far closer, the shockwave itself could reach the outer solar system. The Kuiper belt would be disturbed. Comets would be thrown from their paths. Gravitational balance would shift. The solar system would tremble. Planets wouldn't instantly explode. But they wouldn't stay untouched. Atmospheres could erode. Magnetic shields would be overwhelmed. Technology would vanish in moments. Satellites, gone. Power grids, gone. Communication, silent. Now zoom out. Our solar system feels enormous. From the Sun to Neptune is about 4.5 billion kilometers. Across the entire system, roughly 9 billion kilometers. That sounds vast. But a supernova shockwave can expand for dozens of light years. That's trillions upon trillions of kilometers. Our solar system is not a fortress. It's a speck inside the blast radius. Even from hundreds of light years away, a supernova could appear brighter than the full moon in our sky. During the day, shining against sunlight. And here's the strange part. Supernovae are not rare. In a galaxy like the Milky Way, one explodes about every 50 years. Most happen far away, too distant to matter, but some stars much closer to us are already nearing the end of their lives. Astronomers watch them carefully, giant stars, unstable stars, stars like Betelgeuse. One day, it will explode. Not tomorrow, not next year, but in cosmic terms, soon enough. And yet, supernovae are not only destruction, they are creation. The iron in your blood, the calcium in your bones, the gold in jewelry, those elements were forged inside exploding stars. Every atom heavier than iron was born in a supernova. So, the same force that could erase our solar system is also the reason planets like Earth exist. Destruction creates material. Material forms stars. Stars form planets. Planets form life. A supernova versus the solar system is not really a battle. It's a reminder of scale. If it's close enough, the solar system loses. If it's far enough, we survive. Barely. Space is not calm. It only feels calm because distances are enormous. But somewhere right now, a star is collapsing. A core is imploding. And a future supernova is already on its way. The question isn't if supernovae happen. They do. The real question is distance. Because in space, distance is the difference between a beautiful light in the night sky and extinction.